All right, I'm just going to give you a quick recap of convex lenses and concave lenses right now so you can get going on those practice questions. So we went over in the notes, convex lenses are going to come in and bend light in towards a focal point. Now, I want to show you a video of that actually happening in real time right now. So what you're going to see in the next video is me shining a laser along all of these lines and it always bending towards the focal point. So let me show you that here. And you see what's happening here is the green light is coming out of this laser and then it's striking this lens right here. And then when it strikes this lens, this material here has a higher index of refraction. So it's going to bend towards the normal line, but the normal line here is going to look like this. And when I'm on the other side here, then the normal line is going to look like that. So it bends towards that normal line. And as a result, your light converges to common points over on that side. Now, with convex or concave lenses, you have the opposite situation because your lenses are shaped differently. So I'm going to show you a video. I'm going to insert two videos again here. One of this again, after I talked about it, and then I'm going to show you one right after of a concave lens. So this is similar, light comes out of this laser and it's going to bend towards the normal line, but here because the lens is shaped like this, your normal line is going to be more like this and your light is going to end up diverging. It's going to be diverging as if it came from a common focus over on that side, on the other side of the lens. So I'll insert another video of that. Now I want to show you one more thing that I can do with convex lenses, and I should be able to do this with concave ones too. I just don't have the equipment for it, so I'll have to work on that. So with the concave ones, I told you that they're all the light is converging around some focal point, but it's kind of hard to see it with the laser because all the light isn't coming out at once. So they actually make special equipment in order to kind of see that happen. So it's basically just a light bulb with this kind of screen here. So the light is coming out along roughly parallel lines. But then what happens here if I put a lens that's shaped like this, fix that line here. So if I put a lens that's shaped like this here, well then all of the light should converge at some point over here. Let's see if we can see that happen, and we do. So I think that's kind of cool. I don't know about you. All right, and now we can go ahead and look at some of the practice questions on this topic. We can do one together. So we had a bunch more notes here about these ray diagrams. Talk about them in a second. Let's look at this first one here. Oops. All right, so it says the image produced by this lens. So the first thing that we can do is look up in our notes and figure out which ray diagram this matches up. So see our object is past a focal distance away. So I'm going to want to choose one. It's not quite 2F though. That's at that point. So scroll up. This one's very close. That was our object. So now we're at the focal point. Here we go. So this is going to match up with, and we'll see our image was formed right here, and it's upside down. So I'm going to definitely want to choose one of the ones that are upside down. So it looks like they're using the word inverted. So it's got to be one of those that's inverted. Now, what do they mean about virtual and real? Well, what they're getting at with that is, so you see with these images, on these two, Remember how I had to do these dotted lines in order to show where the image actually was? It was because our eye was over here, and it saw these three rays, and it thought they came from a common point. But there's nothing actually there. Like, the light doesn't actually come from there. So that's called a virtual image. Now, with the real images, you have light that comes like this. So our eye is still over here, maybe, but we see the image as if it came from a point closer there. That's why it's upside down. And it turns out that the light is actually intersecting at that point. So because the light is actually intersecting at that point, I can do something pretty cool, where if I actually put a piece of paper right there, or any kind of screen, I can see the image on that screen. Because what's going to happen is all of that light is going to reflect off of that object. And I'm going to be able to see off that piece of paper, and I'm going to be able to see the image there. So let me show you here how I actually got this set up. So in order to get it to work out well and get a picture of it with a camera, I used a candle. So there's a candle here on this index card, and then light is coming out from that candle, and it's hitting this lens. And it's further away from the focal point. So if I look on this piece of paper, if you look down here, you can actually see the image. And then if you go in here, we can zoom in on it and see this is the image. And it's that image that matches up with my ray diagram, because it's kind of hard to tell. But if you see, this is like the base of the candle, and this is the flame, it's upside down, right? Because the image that was formed from this kind of ray diagram that could be projected onto a screen is always going to be upside down. So if you actually looked at the image that's being projected on from a projector, it's actually upside down in order for it to come up or right side up. Image that is, anything that's projected onto a screen is always going to be upside down. So let me go back to the question we were looking at. It's always, it is a real image. It is not a virtual image because the rays actually intersect, and it was upside down. That's what a ray diagram showed.